Hello friends, in the last video we have completed up to the question number 14. Now we'll see the question number 15. A window is in the form of a rectangular surmounted by a semicircle. If the perimeter be 30 meter, find the dimensions so that the greatest possible amount of light may be admitted now see this here. A window is in the rectangular form and it is a surmounted, a semicircle. ABCD is a rectangle. The radius of semicircle is x. One side is y of that rectangle and another is a 2x. Now here xb the radius of semicircle YB the height of rectangular part of the window AB is equals to DC is equals to 2x and AD is equals to BC is equals to y. Perimeter that is equals to AD plus DC plus CB plus arc APB. This perimeter that is a 30 is equals to y that is a AD, DC that is a 2x. Next is a BC that is a CB is y and this arc which is the semicircle that is circumference that is 1 upon 2 in bracket 2 pi r. Therefore 30 is equals to y plus 2x plus y plus pi x that is 2y is equals to 30. I think that there is some mistake I had done. I had changed here that is a 2y is equals to 30 minus 2 pi minus 2x. The maximum amount of light will be admitted when the area of the window is maximum, and that's why we will calculate here, that is the capital A is equals to area of rectangle ABCD plus 1 upon 2 area of circle, and that's why capital A is equals to, now area of the rectangle, that is, this is the AB, which is the 2x, and AD length into breadth, AB into AD, that is a 2x into y. This is the area of the rectangle, and the area of the semicircle, that is equals to 1 upon 2 pi x square. Now here the value of this y, that is we are taking, this is the 2y, which is in bracket 30 minus 2 pi minus 2x. That's why we are substituting here. Now here is instead of this it is a 2 pi, I had corrected it. The maximum amount of, you treat this y as a pi. The maximum amount of light will be admitted when the area of window is maximum. Therefore, we treat here, that is the area is equals to, again this I am repeating here, this y, this is not the y, this is the pi. I will show you. The maximum amount of light will be admitted when the area of the window is maximum. That's capital A is equals to area of the rectangle ABCD plus 1 upon 2 area of area of circle. That is, this is nothing but the area of semicircle. That is a 2xy plus 1 upon 2 pi x square. And this is here I had changed it, which is the pi x. That is x in bracket 30 minus 2x minus pi x plus 1 upon 2 pi x square. And this is our f of x. Now we'll find out its first derivative. That is here the f of x is equals to 30 minus 2x minus pi x square plus 1 upon 2 pi x square. Its first derivative is a 30 minus 4x minus 2 pi x plus pi x, and that is equals to 30 minus 4x minus pi x its second derivative is minus 4 minus pi. Take the minus sign as a common, then in bracket you will get 4 plus pi. That here is the second derivative is negative, and hence this is the test for the maximum. Now the f dash of x is equals to 0 to find out its extreme values. That is a 30 minus pi plus x, that is a 4 plus pi into x, that's equals to 0. Therefore x is equals to 30 upon 4 plus pi. Now it's a second derivative, which is the negative. Therefore f of x attains maximum when x is equals to 30 upon x plus 4. Therefore area is a maximum when x is equals to 30 upon 4. Therefore 2y is equals to 30 minus 2 in bracket 30 upon pi plus 4 minus pi in bracket 30 upon pi plus 4, that is equals to 60 upon pi plus 4. And that's why y is equals to 30 upon pi plus 4. This is the value of the. Now the length is equals to 2x, that is equals to 2 into 30 upon pi plus 4, and that is nothing but 60 upon pi plus 4. The breadth is equals to b is equals to y, and that is equals to 30 upon pi plus 4. Therefore, the radius r is equals to x is equals to 30 upon pi plus 4. Now again we will see here from the first, a window is in the form of a rectangular surmounted by a semicircle if the perimeter be the 30 meter. Find the dimensions so that the greatest possible amount of light be admitted. Maximum light must be come. Now see this here figure. It is in the form of the rectangular and surmounted with the semicircle. Let x be the radius of the semicircle and y be the height of the rectangular part of the window. AB is equals to DC is equals to 2x and AD is equals to BC is equals to y. The perimeter is equals to AD plus DC plus CB plus arc APB. Therefore, 30 is equals to y plus 2x plus y plus 1 upon 2 pi x. And therefore, 30 is equals to y plus 2x plus y plus pi x. And that's 2y is equals to 30 minus 2 pi minus 2x. The maximum amount of the light will be admitted when the area of the window is maximum. Therefore, we treat here, find out the area. The area of the rectangle ABCD plus 1 upon 2 area of circle. And the area of the rectangle, this is the length, that is AB, and this is the breadth. Whatever that is a 2x. These are the two dimensions. 2x, y plus 1 upon 2 pi x square. Now in this case, that is we'll substitute the value of 2y. This x is as it is, and the value of the 2y is 30 minus 2 pi minus pi x plus 1 upon 2 pi x square. Therefore, f of x is equals to 30 minus 2x square minus pi x square plus 1 upon 2 pi x square. Now the f dash of x, that is a 30 minus 4x minus 2 pi x plus pi x. And if you evaluate it, then you will get 30 minus 4x minus pi x. F double dash of x, that is equals to, find out the second derivative, the derivative of 30 is 0. Minus 4 minus pi. Therefore, f double dash of x is equals to, take the minus sign as common, then in bracket you will get 4 plus pi. F dash of x is equals to 0. That is equals to, the first derivative is 0. Therefore, we will equate here 30 minus 4x minus pi x, that is equals to 0. Therefore, this is a x is equals to 30 upon pi plus 4. F double dash of x is equals to 30 upon pi plus 4, and that is negative. Its value is negative, and here we get the condition for the maximum. This is the f double dash. F attains the maximum when x is equals to 30 upon x plus 4. The area is the maximum when x is equals to 30 upon pi plus 4. Now in second case, we will find out the value of the y. Now we have the 2y is equals to 30 minus 2 pi minus 2x. And here, that's why we will require here, that is a 2y is equals to 30 minus 2 in bracket 30 upon pi plus 4 minus pi in bracket 30 upon pi plus 4, and that is equals to 60 upon pi plus 4. Therefore, y is equals to 30 upon pi plus 4. The length is equals to, L is equals to 2x. That is equals to 2 into 30 upon pi plus 4. That is a 60 upon pi plus 4. Breadth is equals to b is equals to 1. That is a 30 upon pi plus 4. And also the radius is a 30 upon 5 plus 4. These are the dimensions of that windows. Now the next problem is, show that the height of a right circular cylinder of the greatest volume that can be inscribed in a right circular cone is 1/3 of that of the cone. Now in this case, the cylinder is inscribed in this cone. What's the condition that the right circular cylinder of the greatest volume? Therefore, we will find out the volume of this cylinder, and when it is the greatest, then there is a relation that the height of this cone is 3 times the height of this cylinder, or this small h is equals to 1/3 capital H. This we want to prove. For that, the volume of the cylinder is important. Now see this in this figure, OB that is equals to R is equals to the radius of cylinder. OA the radius of the cone. These are the small r and the capital R. OS the height of the cone. OS, this is the height of the cone. O dash O, that is the height of the cylinder, which is the small h. Now if you see these two triangles, that is a S O dash B and S O A, these two triangles are similar. Therefore, SO1 or dash, you consider whatever that, SO dash and SO is equals to O dash B O A. Now we'll substitute the value, that is the SO dash. The value of SO dash, this is the height, this is the part, and that is nothing but capital H minus small h, which is the capital H minus small h. SO that is equals to capital H, and hence O dash B that is equals to this radius small r. OA is equals to capital R, and by using this relation we will find out the value of the small r. This small r is equals to capital R in bracket capital H minus small h upon capital H, and that is equals to capital R in bracket 1 minus small h upon capital H. Now the volume of the cylinder, that is equals to this volume, that is the where it has the maximum volume, which is equals to pi r square into h. Now we'll substitute the y. That is, we want to find out the relation between the capital H and the small h. And here, that is V is equals to, substitute the value, R, capital R in bracket 1 minus small h upon capital H bracket square into h. Therefore, f of h is equals to, which is the pi h, r square in bracket 1 minus 2 h upon small h upon capital H plus h square upon h square, which is the f of h is equals to, now here we will take, that is r square, and this h will be multiplied to this whole bracket. Therefore, pi r square, and here is a h, minus 2 h square upon capital H plus h cube upon capital H. Therefore, differentiate this with respect to the small h. Therefore, the f dash of h is equals to pi r square is as it is. Derivative of this small h is 1 minus 4h upon capital H plus 3h square upon capital H square. Now to find out the extreme values, the first derivative equals to 0. Therefore, we'll equate it and we have this, that is a 1 minus 4h upon capital H plus 3h square upon capital H square is equals to 0. Now evaluate this, multiply on both sides by h square. Therefore, h square is equals minus 4x small h capital H plus 3h square is equals to 0. Now factorize this, that is h square minus 3 capital H small h minus capital H small h plus 3h square is equals to 0. And if you take the capital H common, then in bracket you will get capital H minus 3h minus h in bracket capital H minus 3h, that's equals to 0. And the factors are capital H minus 3h in bracket capital H minus h, that's equals to 0. And that's why the capital H is equals to 3h or capital H is equals to small h. But this is not possible. That is the wall height of this cone and the height of the cylinder. Is it possible? It is not possible. Therefore, we are not taking in the consideration. Therefore, h is equals to 1 by 3 pi h. And that's this we want to prove. Again, if we see this, this is the first derivative, the second derivative, and if we simplify this, substitute the value of this small h, this all will be the in terms of the capital H, and that's the negative, and hence that is the greatest function, and hence the small h is equals to 1 by 3 capital H. This is a very simple simplification. I have substituted the value of this small h, that is equals to 1 by 3 capital H, and simplify this, and you will get pi r square minus 2 upon capital H, which is the negative. Now see this again here. Show that the height of the right circular cylinder is the greatest when that is the greatest that volume that can be inscribed in a right circular cone is 1/3 that of the cone. Now see this again figure here. This is the cone and the cylinder is inscribed here. The capital H, that is equals to small r, that is equals to the radius of cylinder. OA, that is radius of the cone. OS is equals to height of cone. That is O1 dash or O dash O, that is equals to the height of a cylinder. Now these two triangles are similar, that is a SO dash B and SOA. These two triangles are similar. Therefore, their corresponding sides are in proportion. Therefore, SO dash upon SO is equals to O dash B upon OA. These are the proportional sides of that two similar triangles. Now the value of SO dash SO dash, that is equals to capital H minus small h. SO, that is a capital H. O dash B, this is a small r, and OA, that is a capital R. This small r is equals to capital R in bracket capital H minus small h upon capital H. And if we simplify this, that is a small r is equals to capital R in bracket 1 minus small h upon capital H. Now the volume of the cylinder, that is pi r square into h. We will substitute the value of small r as capital R in bracket small h upon capital H bracket square into h. Therefore, f of h is equals to pi h in bracket capital R square in bracket 1 minus small h upon capital H plus small h upon capital H bracket square. And if we take R square as a here rearrangement of the terms, that is a pi r square, and multiply this h to 1 2 upon small h upon capital H plus small h square upon capital H square, then you will get small h minus 2 h square upon capital H plus h cube upon capital H. Now f dash of h, that is equals to derivative of h is 1 minus 4h upon capital H plus 3h square small h square upon capital H. Therefore, f dash of h, that is equals to 0. One minus 4h upon capital H, 3h square upon capital H square, and that's equals to 0. Therefore, capital H square minus 4 small h capital H plus 3h square is equals to 0. Now factorize this. Therefore, capital H square minus 3h minus capital H small h plus 3 capital small h square. If you factorize this, take capital H as a common, then in bracket small h in bracket capital H minus 3h, that's equals to 0. Now these are the factors, capital H minus 3h into capital H minus a small h, that's equals to 0. Therefore, the second is not possible. Therefore, capital H is equals to 3h or capital H is equals to small h. But that is not possible. Therefore, the small h is equals to 1 by 3 capital H. Therefore, the height of the cylinder is equals to the 1/3 of the height of the cone. See this again. We'll find out the second. Now see this, the first derivative f dash of h is equals to pi r square in bracket 1 minus 4h upon capital H plus 3h square upon capital H square. Now we find out the second derivative, that is differentiation with respect to the small h, that is a pi capital R square minus 4 upon capital H plus 6h upon h square. F double dash of h is equals to pi r square 4 upon capital H plus 6 upon h square into 1 by 3. That is, we will in a single variable, that is a small h is replaced by 1 by 3 capital H. And if we simplify this, that is pi r square minus 2 upon capital H, which is the negative. This is the, that is the condition for the greatest function. Therefore, small h is equals to 1 by 3 capital H. That is the height of the cylinder, right? Circular cylinder is 1/3 that of cone. A wire of a length, a small l, is cut into two parts. One part is bent into a circle and the other into a square, so that the sum of areas of the circle and the square is least. If the radius of the circle is half the side of square, radius of circle is half the side of the square. Now see this first of all here. A wire of the length L is cut into two parts. One part is bent into a circle and the other part into a square. Show that the sum of the areas of the circle and the square is the least. If the radius of the circle is half the side of the square. Now here small r be the radius of the circle and small x be the length of the side of the square by the given condition. Therefore, now here the circumference of the circle plus perimeter of the square is equals to small l. Now here we will treat as small r is the radius, that is therefore its circumference is 2 pi r and the x is the side of the square, therefore its perimeter is 4x. That is 2 pi r plus 4x is equals to small l. Now we have given the condition for its area. That is the sum of the area of the circle and the square is a least. That is a condition for the minimum. That area of the circle plus area of the square. That is a pi r square plus x square. Now this is the r. The value of r is a small l minus 4x upon 2 pi bracket square plus x square. And if we rearrange the terms, that is x square, that is a 1 upon 4 pi in bracket L minus 4x bracket square. Therefore, here the f of x is equals to x square plus 1 upon 4 pi in bracket L minus 4x bracket square. Now differentiate this with respect to x. Its first derivative f dash of x is equals to 2x plus 1 upon 4 pi into L minus 4x bracket square. That is a 2 in bracket L minus 4x into again the derivative of L minus 4x. That is the minus 4. And that's why you will have that is a 2x. If we simplify it, then you will get this 4 get cancelled. Minus 2 upon 5 in bracket L minus 4x. Therefore, f double dash of x is equals to 2 plus 2 upon pi into 4. It's a second derivative. That is the derivative of this 2x is 2 and the derivative of this x is 1. That is a 2 pi minus 2 pi into 4. And it's become a plus, that is the pi, the 8 upon pi. That is a 2 plus 8 upon pi. This is second. Now this is the positive and it's a greater than 0. It's a clear that it's a condition for the this. F dash of x is equals to 0. This is the positive. F dash of x is equals to 0. We want to find out the value of the x and f dash of x is equals to 2x minus 2 upon pi to find out its extreme values. In bracket small l minus 4x, that's equals to 0. And therefore it is a 2x minus 2l upon pi plus 8x upon pi, that's equals to 0. And if you simplify this, then you will get 2 pi x plus 8x, that is equals to 2l. And if you take x as a common, then in bracket you will get 2 pi plus 8, that is equals to 2l. Therefore x is equals to 2l upon 2 pi plus 8, and x is equals to, if you take the 2 as a common, then you will get l upon pi plus 4. Now the second derivative, which is a positive. Therefore by the second derivative test, f has the minimum when x is equals to l upon pi plus 4. Now what's the value of the r? That is the r is equals to, now here we have calculated here, or here we'll substitute its a value. That is a 2 pi r plus 4x, that's equals to l. And if we substitute the value, that is a r is equals to l capital L minus 4 in bracket L upon pi plus 4 upon 2 pi. And if we simplify this, then you will get pi L plus 4L minus 4L. Plus 4L and minus 4L get cancelled. Therefore, this small r is equals to pi L upon 2 pi in bracket pi plus 4. Now here pi get cancelled and you will get L upon 2 in bracket pi plus 4, and that's equals to x upon 2. Therefore, that is a sum of the areas of the circle, and this is r. Circle and the square is a least when the radius of this circle is equals to x upon 2. Least when the radius of the circle, that is equals to 1 upon 2 the side of the square. That is x is equals to the 1 upon 2 into side of the square. Now see this again here. R is equals to 1 upon 2x, that's we want to prove. Let R be the radius of circle. Again I am repeating this problem. X be the length of the side of the square by given condition circumference of a circle plus perimeter of square, that is equals to L. That is, therefore the 2 pi r plus 4x, that is equals to L. Now the area is, that is capital A, is equals to area of the circle plus area of square. That is a pi r square plus x square. Now we'll substitute the value of this small r, which is the, from this, that is a 2 pi r plus 4x is equals to L. That is a L minus 4x upon, this is the 2 pi square plus x square. Now rearrangement of the term, this is x square plus 1 upon 4 pi in bracket L minus 4x bracket square. Now let f of x is equals to 1, f of x is equals to x square plus 1 upon 4 pi in bracket minus 4x bracket square. Now differentiate this with respect to x. F dash of x is equals to 2x plus 1 upon 2 in bracket L minus 4x into derivative of L minus 4x and 4. And if you simplify this, then you will get, that is a 2x minus 2 upon pi in bracket L minus 4x. Therefore, f double dash of x is equals to, it's a second derivative of x is 1, and this minus and minus will become plus, that is a 2 pi into 4, that is a 2 plus 8 upon pi. Now this is the positive quantity and this is the condition for the minimum. F double dash of x is equals to 0. Now we will find out its extreme values. F dash of x is equals to 2x minus 2 upon pi in bracket L minus 4x, that's equals to 0. Therefore 2x minus, if you simplify this, then you will get minus 2L upon pi plus 8x upon pi, that is equal, that is a 2x plus 8x upon pi, that is equals to 2L upon pi. Therefore pi x, if we simplify, multiply on both sides by pi, that is a 2 pi x plus 8x, that is equals to 2L. Therefore take x as a common, then in bracket you will get 2 pi plus 8, that is equals to 2L. Therefore x is equals to 2L upon 2 pi plus 8. Therefore x is equals to L upon pi plus 4. F double dash, that is F double dash L upon pi plus 4, that is, it's a second derivative is positive and this is the condition for the minimum. Therefore by the second derivative test, f has a minimum when x is equals to L upon pi plus 4. Small r is equals to small l minus 4 in bracket, we will substitute the value of x. and simplify this. If we simplify this, that is a pi plus 4 into L, that is a pi L plus 4L minus 4L plus 4L minus 4L get cancelled. You will get pi L upon 2 pi in bracket pi plus 4. Therefore, L upon 2 in bracket pi plus 4, that's a bracket is completed. That is equals to x upon 2. That is the radius of the circle is equals to half of the side of the square. The sum of the areas of the circle and square is a least when radius of circle is equals to 1 upon 2 side of the square. Now the next is question number 18. A rectangular sheet of a paper of a fixed perimeter with the side having their length in the ratio 8:15 converted into an open rectangular box by folding after removing the square of the equal areas from all corners. If the total area of the removed square is 100, the resulting box has a maximum volume. Find the length of a rectangular sheet of paper. Now see this again. A rectangular sheet of paper of the fixed perimeter with the sides having the length in this ratio 8:15 converted into an open rectangular box by folding after removing the square of equal areas from all corners. If the total area of the removed square is 100, the resulting box has a maximum volume. Find the length of a rectangular sheet of paper. Now here, let the common multiple be x. We have given there the proportion, that is 8:15. Therefore, the side of the paper are the 15K and the 8K. Suppose that the square of the side x is cut from each corner. Therefore, the base area of the box is equals to, if we cut this from the four corners, and on one side that will be the 1x and another side that will be another x. Therefore 15 minus 2x, and for the same for the other side, from one corner that will be the x and another corner that will be the x, that is 8 minus 2x. Now the volume of the box. Now this is the area of the base, and volume of the box means what? Area of the base into height. That is the 15K minus 2x in bracket 8K minus 2x into x. And that is a 120K square minus 30xk minus 16xk plus 4x square bracket complete into x. And now if we simplify this, then you will get 4x square minus 46xk plus 120k square into x. And therefore v is equals to 4x square minus 46xk plus 120k square into x. Now the area of the square, that's we have given that is equals to x square. Now there are the four corners from each four, that is the four corners, and each of the area is a x square. Therefore the total area, that is we have given that in the question, that is if the total area of the removed square is 100. Therefore, here is 4x square, that is equals to 100. Therefore, x square is equals to 100 upon 4, and that is equals to 25. Therefore, x is equals to 5. Therefore, v of x is equals to that. Now, what we have? V is equals to 4x square minus 46xk plus 120k square into x. And here is if we multiply here with by x, then you will get 4x cube minus 46x square k plus 120k square x. And you will get, that is v of x is equals to f of x. That is the 4x cube minus 46x square k plus 120k square x. Now find out its first derivative differentiation with respect to x. The derivative of 4x cube is a 12x square minus 46x square is a 92xk plus 120k square. The derivative of x is 1. F dash of x, that is equals to, if we take 2 as a common, then in bracket you will get 6x square minus 46xk plus 60k square. F double, that is at the value of, if we substitute x is equals to 5, f dash of 5, that is a 2 in bracket 5 square 46 into 5k plus 60k square. And to find out, we want to find out their extreme values, and if you simplify this, then you will get, if we take the 5 as a common from this, and also 2 and 2 common from this, then you will get, that is a 0 is equals to 2 into 5 into 2, that is a 15 minus 23k plus 6k square. Therefore, you will get this equation, that is a 6k square minus 23k plus 15, that's equals to 0. Now to solve this equation, we will apply the formula that we have learned in the 10th standard. By using the formula, that is a k is equals to the minus b minus 23 minus 23 plus or minus in root of b square minus 4ac. This is the b square minus 4ac. These are the terms. And if you simplify, then you will get 23 plus or minus in root of 250, 559 minus 360. That's 169. And its a square is a 13. Therefore, 23 plus or minus 13 upon 12. Therefore, k is equals to 23 plus 13 upon 12. Or k is equals to 23 minus 13 upon 12. That is equals to 10 upon 12. That is equals to 5 upon 6. Therefore, k is equals to 36 upon 12. Therefore, k is equals to 3. K is equals to 5 by 6. K is equals to 3 or k is equals to 5 by 6. Now, when k is equals to 5 by, that is a k is equals to 5 by 6, that is not possible. If we take it, then you will get this, that is a 8 into 5 by 6, that is equals to 20 upon 3, and that comes to the negative. Therefore, we are not taking that, and we take the value of the k, that is equals to 3. Therefore, the sides of the rectangle are, rectangular paper are the 8k, that is 8 into 3, that is equals to 24. 15k, that is a 15 into 3, that is equals to 45. Therefore, the length of the rectangular sheets are 24 and 45. Now, see this again here. A rectangular sheet of paper of fixed perimeter with the sides having their length in the ratio 8:15. converted into an open rectangular box. By folding after removing the squares of equal area from all corners, if the total area of the removed squares is 100, the resulting box has a maximum volume find the length of rectangular sheet. Now see this here figure. This is the first square, all the squares. Let here the common multiple be x. The side of paper that is equals to 15K and 8K. Suppose that the square of the side x is cut from each corner area of box is equals to 15K minus 2x in bracket 8K minus 2x. Now this is the volume. You simplify this, then you will get f dash of x that is equals to 5 square minus 23K plus 15 is equals to 0. Now simplify this, 5K square minus 15K minus 8K that is a K is equals to 3 or K is equals to 5 by 6. Now k is equals to 5 by 6 is not possible. That is a 8 into 5 by 6. That is a 20 minus 3. This is the side, and if we subtract it, then you will get the negative value of the therefore k is equals to 3. That is the side of the rectangular paper. That is a 8k is equals to 8 into 3, 24. Another is a 15k, 15 into 3, that is 45. Therefore, the length of the rectangular sheets are 24 and 45. Let's see this again here. Volume of the box. Again, I am repeating here. This is the V of x. That is f of x is equals to this is the equation. To solve the equation, we treat here as now see this again here. Therefore, k is equals to 3. The sides of rectangular paper, that is 8k, 8 into 3, that is equals to 24. Fifteen into 3, that is equals to 45. The length of rectangular sheets are 24 and 45. This is why I am repeating again here. Repeated the number of the times. Now we'll see the next example. That is example number 19. Now see this first of all here. Show that the altitude of a right circular cone of the maximum volume, that is we want to find out the volume of the cone. Maximum volume that can be inscribed in a sphere of the radius small r is 4r upon 3. That is the altitude of the right circular cone. This is the height, and that is equals to 4r upon 3, where the r is the radius of the sphere. Now here we have the two types of the radius. One is the radius of the sphere and another is a radius of the cone capital R. The height of the cone small h. Now the volume of the cone, that is 1 by 3 pi r square into h. That is 1 by 3 r square. The value of this small h, which is the height of the cone. Now this is a small r. Now to find out this height, we will require, that is a small r square minus this capital R square. Small r square minus this capital R square. This is nothing but the height of this cone. Therefore 1 by 3 pi r square small r plus in root of r square minus small r square minus r square. Now first of all we will differentiate this dv upon dr, that is equals to 1 by 3 pi in root of, that is a 2r. Differentiation with capital R, which is 1 by 3 pi r 2r, in bracket r plus in root of r square minus small r square minus capital R square plus capital R square. Now the derivative of this small r plus in root of small r square and capital R square. Now here its a derivative is 1 upon 2 times in root of r square small r square capital R square into minus 2r. That is the derivative of minus 2r minus r square. And if you simplify this, then you will get 2r in bracket r plus in root of r square minus small r square minus capital R square minus, this is a 2r minus r cube upon in root of r square small r square capital R square. Now to find out the extreme values, again we will equate the first derivative equals to 0. That is, we will equate this quantity, whole quantity, that is equals to 0, which is given here. That is here, this will be the 0. That is a 2r in bracket r plus in root of small r square minus r square minus r cube upon in root of small r square minus capital R square is equals to 0. And if you simplify this r get cancelled, you will get the capital R square. That is a 2 in bracket small r plus in root of small r square capital R square into in root of small r square capital R square minus r square, that's equals to 0. And again to simplification, that is a 2r in root of r square minus small r square minus capital R square plus 2 in bracket small r square minus capital R square minus r square, that's equals to 0. And again we will simplify here, that is after simplifying, this is a 2r square minus 2r square, that will become minus 3r square. If the whole term is to the right hand side, it becomes 3r square minus 2r square, and that's why squaring on the both sides, then you will get, this is the 4r square r small r square minus capital R square, that is equals to 3r square minus 2r square bracket square. Now simplify this again, that is multiplied this 4r square to this r square minus capital R square, that is 4r raised to 4 minus 4r square capital R square, 3r raised to 4 minus 12x, that is expand this, that is a 12 capital R square plus 4r square. And if you simplify this, then you will get minus 4 r square r raised to 4 plus 12 r square capital R square small r square, that is equals to 9 r raised to 4. And again simplifying this, you will get, that is a 8 capital R square small r square, that is a 9 r raised to 4. Therefore 8 r square is equals to 9 r square. Therefore the capital R square is equals to 8 upon 9 r square. Now what's the value of this small h? The small h is equals to small r plus in root of r square small r square minus capital R square, which is nothing but the height of this cone, and that's why we have here the value. If you simplify this, then you will get small h is equals to small r plus small r upon 3. That is a small h is equals to 4r upon 3. Therefore, that's why the small h is equals to 4r upon 3, which we want to prove. Now see this again here. Show that the altitude of right circular cone of maximum volume that can be inscribed in a sphere of a radius small r is 4r upon 3. That is the altitude of this. This small h is equals to 4r upon 3. This we want to prove. Now the radius of the sphere is a small r. Radius of cone is a capital R. Height of cone, that is a small h. Volume of cone is equals to 1 by 3 capital R square into h. That is 1 by 3 pi capital R square in bracket. The value of h is h plus in root of r square, small r square minus capital R square. Now the volume that is a dV upon dr. The volume should be the maximum, therefore we'll differentiate with respect to the capital R. That is 1 by 3. The derivative of this is 2r. Use the product rule here. R small r plus in root of capital R small r square capital R square as a constant. And again here plus capital R square in bracket 1 upon 2 times in root of small r square capital R square into minus 2r. And if you simplify this, then you will get 1 by 3 pi in bracket 2 capital R in bracket small r plus in root of small r square r cube minus r cube upon in root of r square minus capital R square. Again the simplification of this, that is a 2r in bracket in root of small r square minus capital R square minus r cube upon in root of small r square minus capital R square is equals to 0. That is the RR get cancelled. We can eliminate from these two. That is a 2 in bracket small r plus in root of small r square capital R square minus r square upon in root of small r square minus small capital R square, that's equals to 0. That is a 2 in bracket small r plus in root of small r square minus capital R square into in root of small r square minus capital R square minus r square, that's equals to 0. And if we simplify, that is a 2r in root of small r square capital R square plus 2 times in root of, and this root will get cancelled, that is r square small r square minus capital R square minus r square, that's equals to 0. Now simplify this. If we simplify this, that is a 2r square minus 3r square. To the right hand side, it becomes 3r square minus 2r square. Now again squaring on both sides. That is a 4r square in bracket small r square minus capital R square, that's equals to 3r. Here is a bracket square. Now expand this. 9r raised to 4 minus 12r square small r square plus 4r square. These two terms get, this is r raised to 4, by mistake it is a 2, but this is r raised to 4. These two terms get cancelled. This is treated as r raised to 4. If we simplify this, that is a 4 small r square r raised to 4 plus 12 r square capital R square small r square is equals to 9r raised to 4. And this is the 8r square capital R square small r square is equals to 9r raised to 4. This is the 8 small r square is equals to 9 capital R square. Now here we have the small h is equals to small r plus in root of small r square minus capital R square. Capital R square is equals to 8 upon 9 small r square. And if we simplify it, then you will get small r square upon 9, which is the small r plus small r upon 3. That is h is equals to 4r upon 3, and that's why this we want to prove. Now the next problem is, show that the height of the cylinder of maximum volume that can be inscribed in a sphere of the radius capital R is, that is the height of this cylinder, that is equals to 2 capital R upon root 3, where capital R is the radius of the sphere, and also find the maximum volume. Now let us see here. Now here the cylinder is inscribed in the sphere. The radius of sphere is capital R and the radius of the cylinder is a small r. Now if we see this, the BC, that is equals to capital R square minus x square. Therefore the volume of the cylinder is equals to, that is a pi r square into h. And if we substitute the value, that is a BC, that is equals to, this is the BC square and this is the small h, which is the height of the cylinder. This is the CD. Now this x plus x, that is equals to 2x. Therefore pi in bracket capital R square minus x square bracket square into 2x. This is the 2 pi and the square of this, that is a capital R square minus x square into x. Therefore v is equals to 2 pi in bracket capital R square into x minus x cube. And therefore dv upon dx is equals to 2 pi. The derivative of capital R square into x, that is the derivative of this x, is 1. And x cube is a 3x square. Now we'll find out the second derivative, that is a d2v upon dx square. This is the 0 and it is a minus 6x. and therefore this is equals to minus 6x, which is less than 0. d2v upon dx square, that is equals to minus 6x, which is less than 0. Now dv upon dx, that is equals to 0, that is equals to 2 pi in bracket r capital R square minus 3x square. To find out the extreme value, it's clear that the value of x is not negative, and therefore we have, this is the condition for the maximum. But till we are going to find out the value, therefore that is a capital R square minus, that is we want to find out the value of that x. Therefore if we simplify this, that is x square is equals to capital R square upon 3 and x is equals to capital R upon root 3. Now we want to find out, that is the altitude, that is the height of the cylinder, that is here is a x and x, that is equals to 2x, that is a 2 capital R upon root 3, and this is we want to prove. This is the x and this is also x, and that is the 2x. Now here we can also find out its maximum volume of that cylinder, that is pi r square into small h. The value of this height is a 2r upon root 3. Therefore the value of the small r is a capital R square minus x square. If we substitute the value of small x, which is r upon root 3, then if after simplifying you will get 2 capital R square upon 3, and the value of this h, that is a 2r upon root 3, and it's a maximum volume, that is a 4 upon 3 root 3 pi r cube, and hence we have the maximum volume, that is a 4 upon 3 root 3 pi r cube, and h is equals to 2r upon root 3. Now the next problem is, that is a problem number 21. Find the maximum and the minimum values of the function f of x is equals to cos square x plus sin x. Now we have the function f of x is equals to cos square x plus sin x. Now differentiate this with respect to x. F dash of x is equals to 2 cos x into derivative of cos x, which is minus sin x, and the derivative of sin x is a cos x. And if you simplify this, then that is you will get minus 2 sin x into cos x, and this is a cos x. This is f dash of x. F dash of x is equals to, take cos of x as a common, then in bracket you will get 1 minus 2 sin x. Now differentiate this again with respect to x. Here is the derivative of cos of x is a minus sin of x, and keep this term as it is. We will apply the product rule. Plus cos of x and derivative of 1 minus 2 sin x, that is equals to minus 2 cos x, and if we again simplify it, then you will get minus sin x plus 2 times sin square x minus 2 cos square x. And if you take the minus 2 as a common, that is a minus sin x minus 2 in bracket cos square x minus sin square x, and this is a cos of 2x, that is a minus sin x minus 2 cos of 2x. This is the second derivative. If you take the minus sign as a common, then you will get sin x plus 2 times cos of 2x. Now to find out the extreme values, that is f dash of x, that is equals to 0. Therefore the cos of x into in bracket 1 minus sin of x, that's equals to 0. It means that here cos of x into in bracket 1 minus 2 sin x is equals to 0. Cos of x is equals to 0, or 1 minus 2 sin x is equals to 0. Now whereas cos of x is equals to 0, or the sin of x is equals to 1 upon 2. Now the values are here. What will the values? That is x is equals to, first is pi by 6, and x is equals to, next value will be the pi by 2, where this cos will become 0, and next is a 5 pi by 6. Then you will get again the sign is positive, and which value is again 1 upon 2. Now for the second derivative test, if you see this, it's a value, that is for which value it will apply, that is the maximum and the minimum. Now if we substitute, that is x is equals to pi by 6, then you will get minus, that is a minus in bracket 1 upon 2 plus 2 into 1 upon 2. That is, here is a pi by 3 and cos of pi by 3 is 1 upon 2. That is a minus 3 by 2, which is the negative. Therefore, the given function has a maximum at x is equals to pi by 6. This is the first. Next is, what will that maximum value? That the maximum value is equals to, that is a cos square x plus sin x. If we substitute x as a pi by 6, that is the cos of pi by 6 is the root 3 upon 2 bracket square and sin of pi by 6, which is 1 upon 2. That is the 3 by 4 plus 1 upon 2, which is a 5 by 4. This is the maximum value. And the next is, if we substitute x is equals to pi by 2, then what will happen? That is a second derivative. Then you will get sin of pi by 2, that is 1, and 2 times, that is 2 into pi by 2. This 2 get cancelled, which is cos of pi. That is a 2 minus 1, and overall you will get 1 minus 2, which is a minus 1, and minus minus will become plus, and which is a greater than 0. Therefore, the given function is a minimum at x is equals to pi by 2. And what is its a minimum value? Now we'll calculate here and substitute here x is equals to pi by 2. That is a cos square pi by 2 plus sin of pi by 2. The cos of pi by 2 is a 90, that's a 0. And sin of pi by 2, that is equals to 1. This is the minimum value. Therefore, the maximum value is a 5 by 4, and minimum value is 1. Now see this again. Find the maximum and the minimum values of the function f of x is equals to cos square x plus sin x. F of x is equals to cos square x plus sin x differentiate with respect to x. It's a first derivative. That is the 2 times cos of x into derivative of cos of x is a minus sin x plus derivative of sin of x is a cos x. Therefore, here is a cos x and minus 2 sin x into cos x. This is the f dash of x. That is a cos x minus 2 sin x into cos x, and that is nothing but the sine of 2x. F dash of x is equals to cos x. If you take the cos x as common, then in bracket you will get cos x minus in bracket 1 minus 2 sin x. Now differentiate this with respect to x. It's a second derivative, that is a minus sin x. Derivative of cos of x is minus sin x into in bracket 1 minus 2 sin x plus cos of x into in bracket derivative of 1 minus 2 sin x is a minus 2 cos x. Now this is the f dash of x, and simplify this. That is the minus sin x plus 2 times sin square x plus minus 2 cos square x. There is a minus sign. This is the minus sin x. We can take the minus 2 as common, then you will get cos square x minus sin square x. Here is a minus sin x minus 2 cos of 2x. Cos square x minus sin square is nothing but the cos of 2x. Therefore, it's a second derivative. We take the minus sign. Now we will find out the extreme values. That's the first derivative, f dash of x is equals to 0, which is the cos x in bracket 1 minus 2 sin x. That is equals to 0. It means that cos x in bracket 1 minus 2 sin x is equals to 0. Therefore, cos x is equals to 0 or 1 minus 2 sin x is equals to 0. Therefore, cos x is equals to 0 or sin of x is equals to 1 upon 2. X is equals to pi by 6. These are the possible values. X is equals to pi by 2 and 5 pi by 6. Now f double dash of x. That's it's a second derivative, which is the minus sin x plus 2 times cos of 2x. And if we substitute first of all the first value, which is the pi by 6, then you will get sin of pi by 6, that is equals to 1 upon 2 plus 2 times cos of 2 pi by 6. Now cos of pi by 6 is 1 upon 2. 2 into, again here is 1 upon 2, that is cos of pi by 3. Its value is 1 upon 2. And if we simplify it, then you will get minus 3 by 2, which is the condition. This is the condition for the maximum. I forget to write here double dash. Therefore, the given function is a maximum at x is equals to pi by 6. Therefore, f of x is equals to cos square x plus sin x. F of pi by 6 is equals to cos square pi by 6 plus sin of pi by 6. And if we substitute, then you will get, we want to find out its maximum value, which is root 3 upon 2 bracket square plus 1 upon 2. 3 by 4 plus 1 upon 2, that is equals to 5 by 4. Therefore, the maximum value is 5 by 4. At x is equals to pi by 2, f double dash of x, that is equals to minus sin x plus 2 times cos 2x, that is sin of pi by 2 plus 2 times cos of 2 pi by 2. 1 plus cos of pi, and cos of pi is a minus 1. That is a minus in bracket 1 minus 2. That is minus in bracket minus 1, which is the positive, and this is the condition for the minimum. Therefore, the given function is a minimum at x is equals to pi by 2. And what is its a minimum value? That is a cos square x plus sin x. That is a cos of pi by 2, cos square pi by 2 plus sin of pi by 2. That is cos of pi by 2 is 0 and sin of pi by 2 is 1, and hence its a minimum value is 1. Hence the maximum value is a 5 pi by, that is a 5 by 4, and minimum value is 5 by 4, and the minimum value is 1. And in this way we have completed the second chapter, that is the application of the derivatives. Now we'll see in the next video for the chapter integration. That is, we have completed the first exercise 3.1. Now we'll start the next exercise, which is the 3.2. I hope that you would have understood the problems I had explained. Now we'll see in the next video. Goodbye.